Today's section on circles, chapter 10, is the power theorem. So this has to do with various types of intersections that can occur in our circles with our different chords, secants, and tangents. So the first one we're going to talk about is the chord-chord power theorem. And that is that if we have two chords intersecting inside the circles, then they do so proportionally. So we can take their products, meaning their multiplications of each chord, and they will be equivalent to each other. So if Vn is pink and Sl is green, then pink times pink is equal to green times green when I have two intersecting chords. That's our first power theorem. Our second one is the tangent-secant power theorem, and this means I have a tangent segment. I'm going to color code that one green, meaning it touches the circle once, and I have a secant segment that touches the circle twice. And that relationship is the tangent segment squared is equal to the product of the two pinks, the way that it is split. So green squared equals pink times pink for tangent secant. And the last one we have is secant secant. So if I have two secants, meaning they intercept the circle twice, that is split up as in, I'm going to color code my two big ones, yellow and blue. So the whole length of the tangent, or excuse me, the secant, and then I have my two shorter outside secants. So in this relationship, yellow times green is equal to blue times pink. And we're going to see all of these in action in just a moment, so don't you worry. But those are our three. We've got chord-chord, tangent-secant, and secant-secant. So let's jump into some examples. I'm going to keep this page handy to refer to. And on the back side with these practice problems, the first thing I want to identify is which relationship I have. So starting on A, these are two chords. So this is going to be my chord-chord power theorem. And remember on chord-chord, it was pink times pink equals green times green. So I'm going to label one of them green, one of them pink. And so 6 times 2 is equal to 3 times x. Green times green, pink times pink. Well, 6 times 2 is 12. If 12 is 3x, then x is 4. It's that easy. Okay, let's look at number 2. I have a tangent and a secant. So this is going to be my tangent-secant power theorem. And for tangent-secant, I had my tangent as green, and green squared equals pink times pink. So let's go ahead and label. Here is my tangent, that one's y, and then my two pinks are 16 and 2. So y squared is equal to 2 times 16. That is my green squared and pink times pink. Now 2 times 16 is 32. If I'm square rooting both sides, 32 is not a perfect square, but it has a factor 16 that is a perfect square. So y is going to be 4 square root of 2. All right, on to 3. I've got two secants, so this is going to be my secant-secant relationship. And for secant-secant, I had 4 different colors because we were looking at the whole length and the partial outside my circle. So I'm going to go ahead and label those. Z, this whole segment is going to be my yellow. This whole segment is going to be my blue. Then 3 is my green. 4 is my pink. So my relationship is yellow times green. So Z times 3 is going to equal blue times pink. Well, blue is going to be 4 plus 8, which is 12. So that was yellow times green equals blue times pink. So 3z is going to equal 48. If I divide both sides by 3, I get 16. Okay, let's see each of those one more time. Let's look at example 2, starting with A. Again, I have the chord. So 3 times x is going to be equal to 5 times 9. So if 3x equals 45, that means x is 15. Okay, on B, I've got a tangent and a secant, so this is my tangent secant. And so my tangent is y, so y squared is going to be equal the 2 parts of the secant, 4 times 12. So y squared is 48. 48 is not a perfect square, but 16 is a factor of it. So if I simplify this, I'm going to get that y is 4 times the square root of 3. And then last but not least, I have a secant theorem. So it's going to be the whole times the part, so that's going to be z times 3 is equal to the whole of the other secant, 10 plus 5 is 15, and that smaller part is going to be 5. So 3z equals 15 times 5 is 75, divide both sides by 3, and I find that z is 25. And so that is how you use your power theorems chord, tangent secant, or secant to find missing pieces.